In this lecture, we will discuss about the importance or significance of RMS value in electrical systems, and we will discuss about the form factor and peak factor. So this lecture will cover the uh, some information about why we use RMS value in electrical systems. What is a form factor? What is peak factor? How to calculate form factor and peak factor of an alternating signal? So we would be discussing one or two numericals also in this lecture. Now, what is the importance of RMS value? As we all know that RMS value is basically the uh, DC of an AC. As we have already discussed in our previous lecture that uh, because our alternating signals are continuously varying with the time, so they are time varying quantities. Like if we talk about a sinusoidal AC is varying with time. So this has the instantaneous value at every point of time, and it is different. It is differing, right? So it has two peak values, one for positive, one for negative. It has the average value, which is zero for complete cycle. Now, if I say that I have an AC source and I have a bulb connected across that AC source, and this AC source is, let us say, 220 volt and 50 hertz. So if I ask that what is the amount of current flowing here in this particular wire which is connecting this lamp and this source, right? Whether it is, uh, if we say, if let us say this is a current basically, okay, and the peak value is, for example, here is 230 volt, and some RMS values, let us say 220 volt, average value is little bit down here, and then instantaneous value is something different at every instant. So if I say that what is the amount of current flowing in this particular wire, which is lighting this particular lamp, so it would be very difficult for us to use the instantaneous value as the magnitude for the RMS value. It would be difficult for us to use the peak value also, because the peak value is also twice. So whether we have to take the positive value or negative value, it would be difficult for us to take the average value also, because the average value is zero for complete cycle. Then there has to be some standard value which can indicate the magnitude of the alternating signal, right? So if we talk about the RMS value, so the RMS value, for example, for the sine wave, it is 0, it is pi, and it is 2 pi. If this is, let us say, a current basically, or it can be voltage also, one and same thing, because the RMS value of a sinusoidal voltage or sinusoidal current would be same. Now, if we calculate the RMS value of this, the RMS value is basically can be calculated by using a simple formula, which is IRMS is equal to under root 1 by T, 0 to T, and I square dt. So this is the formula. Now, here T is basically the time period. Now, whether you calculate the RMS value for half cycle or for full cycle, it is same. You can calculate it. Okay, so that would come the same value. So this indicates that the RMS value will remain same and constant for an alternating signal. So because it is a constant value, it is a unidirectional value of an alternating signal. So that is why we call it as DC of an AC signal. Because if you see a DC, so DC is basically a constant and unidirectional. So we have adapted globally the RMS value to indicate or to signify the magnitude of the alternating signal. Whenever you see some voltage rating or current rating, like if you see somewhere like 220 volt 5 ampere. So this 220 volt 5 ampere indicates the RMS values. It does not indicate the peak value. It does not indicate the instantaneous value. It does not indicate the average value. It indicates the RMS value, right? So a second thing is that RMS value basically indicates the effective value of the alternating signal. So that is why we call it as the effective value also. Right. So if I say that some 10 ampere current is flowing in this wire, so this 10 ampere is not peak value. It is not the instantaneous. It is not the average, but it's RMS. So that is why it is said that RMS value indicates the effective. So effective current that is flowing in this particular wire is 10 ampere, which produces a certain effect here, and this lamp glows, or this lamp dissipates the power. So your RMS value is somehow somewhere related to the dissipation of heat in the electrical systems. Or dissipation of heat means dissipation of power, right? So this is how we can relate the RMS value as an important factor or important uh, component of the electrical system. However, when we are dealing with the insulators, we use the peak value basically. So this is given the importance. Okay, peak value is important here, right? Because if you see the sinusoidal signal, let us say a current basically. So RMS value will be 0.707 of the peak value. The RMS value of a sine wave is 0.707 of its maximum value, peak value. So peak value is always greater than IRMS. So whenever insulation is designed or insulators are concerned, so we do not consider the RMS value. This is not considered. Because if you consider the RMS value to design the insulator, the peak value, because it is greater than the RMS value, so the signal, the current or voltage may break the insulation also. So it can damage the insulation of the electrical systems. And insulations are uh, done to protect the electrical systems from any kind of mishappening or damage from the high voltage or high current, right? So because alternating voltage and current is always specified in terms of RMS, so it is one of the important factor which we have in the electrical systems. As discussed already in previous lecture, that RMS value is basically that value of an alternating quantity which produces the same heat, same effect in the electrical load which is produced by the DC which flows in the same load for the same time, right? So your RMS value gives the measure of the energy content in the alternating signal, in the given signal. Every signal may have the RMS value, right? Uh, because in DC we have all the values same, it is constant and unidirectional. So ideally it has the now, if we talk about the ratings of the electrical appliances I just discussed, if it is written to 30 volt AC, so it means it is the RMS value of that particular electrical appliance, right? So until unless it is specified, all the values which are mentioned means value of voltage or current which is mentioned uh, with the electrical appliances as their rating, they must be assumed as the RMS value. Okay. Otherwise, it would be specified whether the given voltage is the peak value or instantaneous value or average value or what. So that would be specified there. If it is not specified, in that case, you will assume that AC value as the RMS value, right? So if some alternating current of 5 ampere, let us say for example, is flowing in a circuit, so that means that alternating current is producing the same effect in that circuit which is produced by a 5 ampere DC. So this is what RMS value is technically. And one of the very important advantage of RMS or AC signals is that your AC current basically takes less amount of charge to supply the same amount of DC power, right? So that means to run a particular electrical load with DC and AC, we need less amount of AC power as compared to DC. Now let us discuss the form factor and peak factor. Basically, form factor and peak factor are also few important, you know, components associated with the AC signals, alternating signals. So basically, apart from the peak value, average value, or RMS value of the alternating quantity, uh, we have some other components also, which are form factor and peak factor, which relate the peak value, average value, and RMS value with one another. So basically, these factors relate mathematically all these three components: the peak value and the average value and the RMS value of an alternating quantity. Now, what is a form factor? A form factor is basically the ratio of RMS value to the average value of the alternating quantity. It is represented by Kf, which is the RMS value, and divided by the average value of the given alternating quantity. So that alternating quantity can be a sine wave, it can be a square wave, it can be a triangular wave, it can be any random alternating signal, right? So which possesses the RMS value and average value. So we can, if we know these two components associated with the signals, we can find out the form factor, right? So it is basically a mathematical relationship between RMS value and average value. The value of form factor basically depends upon the waveform of the alternating quantity, which type of waveform we are, using or, utilizing or discussing, right? The minimum value of form factor could be one in case of square wave or rectangular wave, because in case of your square wave, let us say, so for a square wave or a rectangular wave, The RMS value and average value are same basically. So you can see that average value is, if this is some current, for example, okay, so it is the peak value here. So peak value is same and the average value is same, means the IP, and RMS value is also IP in this case. So the minimum value of form factor could be 1. uh, and it could be as high as 5, means for some other types of alternating signals, alternating quantities, it can be maximum up to 5. For a sine wave, for a sinusoidal voltage or sinusoidal current, the form factor is basically given by this equation here, and which is equal to 1.11. As we know that the RMS value of a sine wave is equal to 0.707 of the peak value. I'm taking current as an example. However, for voltage also it is same. The VRMS is equal to 0.707 of the peak value of the voltage, and the average value of current, or V average, is equal to 0.637 times of the uh, you know peak value of the current or peak value of the voltage. So by putting these values here, we have form factor equal to 1.11. So form factor basically gives the measure of peakiness. Peakiness means the amplitude of the waveform or the signal, the alternating quantity, right? Peakier the wave, the greater is its form factor, or vice versa. Peakier means, you can see, if you compare sine wave with a square wave, let us say, or a rectangular wave. So sine wave is quite peakier. It has one peak here. It is quite sharp as compared to a square wave. And if you compare a triangular wave with a sine wave, so triangular wave is more peakier than the sine wave. So it has a sharp peak here. Sine wave doesn't have a sharp peak, and square wave or rectangular wave is quite flat at the top. So, for instance, a sine wave is peakier than this. Okay, so the purpose of form factor, or use of form factor, is basically in the rectifier services, means the rectification of the signals, alternating quantities. Now let us come to the peak factor. So peak factor is again our mathematical relationship between the maximum value of an alternating quantity and the RMS value of the alternating quantity. So peak factor is basically the ratio of the maximum value of alternating quantity to the RMS value of same alternating quantity, and it is represented by Kp. Peak factor depends upon the waveform of the alternating quantity, like the form factor. Similarly, peak factor also depends upon the waveform of the alternating quantity. For any sinusoidal signal, the peak factor is given by the maximum value divided by 0. Because RMS value is 0.707 of the maximum value in case of sine wave. In case of sine wave, right? Okay, so we have this. Okay, so for sine wave, these values are constant, right? These values are constant. Whatever is the maximum value of sine wave, whatever is the average value. So for sine wave, kf is 1.11 and kp is 1.414. So these are fixed, right? Peak factor has a little bit more importance as compared to form factor, because it indicates the maximum voltage being applied to various parts of the apparatus. Apparatus means electrical appliances, right? When an alternating voltage is applied across a cable or capacitor, the breakdown of insulation will depend upon the maximum value, right? This is what I was talking about. So whenever we are talking about the insulation uh, of the electrical system, so we does not we generally do not consider the RMS value. We consider the maximum value of the alternating voltage or alternating current. Okay, so the insulation, because the insulation must be able to withstand the maximum rather than the RMS value. Okay, if you consider the RMS value, because maximum value is greater than RMS value. So there is a possibility that your insulation may get damaged. Peak factor, which is also known as crest factor and amplitude factor. So these are the other names of peak factor. Now let us come to numerical here, which I have already solved for you, just to make you understand how to calculate the RMS value, average value, form factor, and peak factor of the given signal. So here, as per the statement, you can see the uh, you know voltage is basically given. The alternating voltage is given here, which is V is equal to 200 sine 314t, and it is applied to a device. The name of the device is not given here, but it is mentioned that this device offers some resistance to the current, which is 20 ohm, and it allows the current to flow in one direction and prevents the flow of current in the opposite direction. So this is actually acting as a diode. Basically it is acting as a diode because diode allows the current to flow in forward direction but does not allow the current in the opposite direction, right? So we have to calculate the RMS value, average value, form factor, and peak factor of the given signal. Now, as from the statement, it is observed that it is a kind of half-wave rectification, right? And so the maximum value, so the components which are given here are the instantaneous value of the voltage and the resistance offered by the device to the current. So the peak value can be calculated. Now, in this particular equation, if you see, this indicates the peak value of the voltage. 314 indicates omega, the angular frequency, because if you compare this with V is equal to Vm sine omega t, so Vm is equal to 200 volt and omega is equal to 314 radian per second, right? So the peak value of current is calculated by using this expression, simply Ohm's law, Vm by R. So it is 200 by 20, and we have 10 ampere of the peak value of current that is flowing in the circuit. Now, if we assume that this is a half wave rectification, so for the half wave rectifier, uh, the RMS value is basically Im by 2 and average value is Im by pi. So this can be calculated in this way. If you consider it to be the half wave rectification, so it is something like this. So from 0 to pi, you have a rectification. From pi to 2 pi, you have 0. And the peak value of this is 10 here, if it is a current IT. Okay, so you can apply the same formula, 1 upon for half wave rectification, the time period is this. This is the time period, which is 2 pi. So average value can be obtained by using this formula, 1 upon 2 pi, the time period 0 to pi. And so this is I is equal to Im sine theta. So it is Im sine theta d theta, right? So because from pi to 2 pi you have 0, so we don't have to mention that here, right? Okay, no need to mention it here. So similarly, you can find out the RMS value also. The RMS value can be obtained by this formula, 1 upon time period, which is 2 pi here, 0 to pi Im square sine square theta d theta. Okay, so I'm not putting the value from pi to 2 pi because it is already 0 in this particular span here, right? It's 0. So by using these formulas, we can calculate and we will obtain that I RMS is Im by 2 and I average is Im by pi. So Im is 10 ampere. So we'll put them here and the values obtained are given here. So the form factor can be obtained by dividing RMS with the average value, because form factor is the ratio of RMS to the average value. So which is 1.57, and similarly peak factor can be obtained as 2. So this is how you can calculate. Okay, this is a simple straight formula put question. So you just need to calculate the RMS and average value to get the value of form factor and peak factor. Now let us see second question here. So in this question, We have a current basically which has certain steady values which are mentioned here in this, and the values are in ampere, which are at equal interval of time. So these values are 0, 10, 20, 30 ampere, 20, then 10, then 0, and then negative values are there. So if we draw the signal based on these values, the signal will look like this. You have from, let us say, if you divide this, so you have this instant here, second instant, third, and then this one, and then this one, and this one. So you have 1, 2, 3, 4, 5, 6. So there are total six intervals. This is one interval, then second interval, third interval, fourth interval, fifth, and then sixth interval is there. So if you have to calculate the average value of this one, how will you calculate? It is very simple. Average value is you add all these. So because it is a symmetrical signal, it is a symmetrical. Uh, this is a symmetrical AC, right? So for the complete half cycle, the average value is 0, right? So we will calculate the average value for half cycle only. Okay, so we'll add all these 0 plus 10 plus 20 plus 30 plus 20 plus 10, 1, 2, 3, 4, 5, 6 intervals are there, divided by number of intervals. So this will be 30, 30, 60, and 90 by 6 ampere. So the value here will be, what will be the value? 1, 5, 15 ampere, right? So this is the average value here. Similarly, if you have to find out the RMS value in this case, so how will you find out the RMS value? So RMS value is root mean square. Square of what? Square of all the instants. So 10 square plus 20 square plus 30 square plus 20 square. Again, for a symmetrical AC, whether you calculate the RMS for half wave or full wave, that would remain same because of the square, because you are squaring the uh, values. So whether it is a positive value or a negative value, that would be same. Positive, okay? Negative ka square b is also positive, and positive square is also positive, right? So plus 10 square divided by 6. So this is equal to 0 plus you have 100 plus you have 400, you have plus 900, you have 400, and then you have 100 divided by 6. Now this is the mean basically. So you have to, this is a square, and then you have calculated mean and root of this particular mean. So this would give you the root mean square value. So this is 1, 5, and 1400 and 1500 and 1900 divided by 6, and then square root, right? So the answer would be, so the value of RMS current would be 17.8 ampere. Now if we have to calculate the form factor and peak factor here, so it is quite simple. The form factor can be calculated by dividing the RMS value of this current to its average value. So this would be 17.8 divided by 15, and similarly the peak factor can be calculated by dividing the peak value. Now peak value here is 30, sorry, maximum value divided by the RMS value, so it is equal to, the peak value is 30 here, and divided by 17.8. So the answers are, so peak factor is 1.68 and form factor is 1.19. So uh, this is one type of case basically. If you find such type of case to solve, so you can solve this in this particular manner. Now let us come to one more type of case to understand, in which we have to ask, we have to calculate the average value, RMS value, form factor and peak factor of the signal which is shown by this particular waveform. Now how to solve this type of numerical and calculate the required values. So in this, if you see, This particular signal is a voltage and its graph is shown here. So from 0 to 1, it is increasing. So it has a slope here, right? And from 1 to 2, it is flat, right? So this whole part is divided into two here. So this would be your V1 and here this is your V2, right? Okay, so from 1 to 2. And if you see it is repeating, so the time period is total time period is 2. uh, Let this be in second basically, however the unit is not mentioned here, so we'll assume it in second, right? 2 seconds. Now what you will do, if you have to find out the average value, the formula for average value is same, 1 upon t integration from 0 to t v dt. Now here t is basically 2 seconds. I'll take it in seconds here, right? Though it is not mentioned, but I have assumed it is in seconds, right? uh, and v is basically divided into two components, two parts. V1, which is equal to some slope. It exists from 0 to 1, and V2 exists from 1 to 2, right? So that means this particular formula will be divided into this one. So you have uh, V average is equal to 1 upon 2 integration from 0 to 2. You have you know uh, V1 dt. So we'll take not 0 to 2 here. We'll take it as 0 to 1 and then integrate the second part, which is from 1 to 2, which is V2 dt, and then close it. So if you see here, now what is V1? If you have to find out the V1, so V1 is basically, you can calculate it using uh, the simple equation of line. So these two coordinates are 0 and 0 here, and here you have the coordinates which is 1 and 1, right? Okay, so this is 1 and 1 here. So we'll take we'll use this formula, y minus y1 is equal to y2 minus y1 divided by x2 minus x1 into x minus x1. So in this case, y is equal to v1 and y1 is equal to 0, x is equal to t, and x1 is equal to 1 here, and y2 is equal to, what is y2? Y2 is again 1 and x2 is equal to 1 here, right? So x2 is also 1, y2 is also 1. So we will see uh, what could be the answer. So let us solve this. So you have v1 minus 0 is equal to y2 is 1, 1 minus 0 divided by x2 is equal to 1, and x1 is not 1 here, mistake done. So it is 0, 0, and you have x is t and x1 is 0, right? So the equation is v1 is equal to t. So this is the equation for the slopey line here, and this is from t is equal to 0 to 1. Now v2 is simple, v2 is totally flat, it is equal to 1 because it is flat throughout. So it is from t is equal to 1 to 2, right? So we will use these two values in this particular formula and we'll try to find out the answer, right? So let us erase this one. So by putting the values of v1 and v2 in this equation, we have this. So we have 1 by 2 and integration of t is t square by 2. So it is from 0 to 1, and integration of 1 with respect to dt is t, and it is from 1 to 2, right? So on solving this, we have 1 by 2 minus 0 and plus 2 minus 1. So this is 1 by 2 and this is 1 by 2 plus, and this is 1 here. So this would be, what is the value here? 3 by 2 and then 3 by 4 volt. So this would be the average value in this particular case. So now we can find out the value of RMS value of this particular signal in the same way. So we'll note down this particular equation. So this is, we'll erase all these things from here. So the RMS value of the voltage can be obtained by using the same formula 1 upon T integration from 0 to T V square dt. So because this signal is divided into two parts, two waves, so we'll do the same thing. Time period is 2 here, bracket start, integration from 0 to 1, V1 square dt plus integration from 1 to 2, V2 square dt and bracket close. So this is under root 1 by 2 and V1 is T square already, right? And dt plus integration from 1 to 2, V2 is 1, 1 square is 1. So 1 square dot dt here, bracket close here, right? So then further we have 1 by 2 and bracket start. So integration of t square is t raised to the power 3 by 3. And this is from 0 to 1 plus, and integration of this would be t from 1 to 2 and then bracket is closed here. And then you have again simplifying this one. You have 1 by 2 t. This is 1 by 3 minus 0 plus 2 minus 1 and under root you have 1 by 2 and this is bracket close here. So bracket close, bracket start, sorry, 1 by 3 and plus 2 minus 1 is 1. So it will be like this. So this would be equal to 1 by 2 into 4 by 3. So the answer is RMS value is 0.8165 volt. Now, if you have to find out the peak factor and form factor of this one, so form factor can be obtained by dividing RMS value of the voltage with the average value. So this would be 0.8165 divided by 0.75. So this would be some answer. And similarly, your peak factor is equal to the peak value. Now, peak value here is 1, right? This is the peak value. So peak value of the voltage divided by the RMS value. So it is 1 divided by 0.8165. So the answers are, so the form factor is 1.0886 and the peak factor is 1.225. So that means in this particular question, what we did is we simply saw a few things. That first is this is a repetitive signal repeating after 2 seconds, right? This is the time period here, and this signal has 2 waves. One is a slopey and second is flat here. So the slopey part would have a different equation, which is P here, V1, and the flat would be having different equation. So we have integrated both for the respective limits from 0 to 1 slope and from 1 to 2 flat. And then we obtained the RMS and average values and then form factor and peak factor of this particular signal. Similarly, we have one more type of signal waveform which you can encounter. So it is a sawtooth wave basically, and in this wave also we have to find out the form factor and peak factor. So because we have to find out the form factor and peak factor, and form factor and peak factor we cannot determine without calculating the RMS values, not values, sorry, value, and your average value. We need to find out these. right? So the process will remain same. We will try to find out the uh, equation for this slope here. So if you see this particular slope, this waveform, it is repeating after 2 seconds. So time period here is 2. If it is in seconds, so it is 2 seconds, right? And it has two coordinates, 0 and 0 here, and here it has 2 and 50, right? Okay, so em is the maximum value, which is equal to 50, right? 50 volt. Okay, so we can find out its equation, which is E is equal to em by 2 into t. If you use the same concept of y minus y1 is equal to y2 minus y1 divided by x2 minus x1 into x minus x1 here. So here y is equal to E, y1 is equal to 0, x is equal to t, x1 is equal to 0, y2 is equal to em, which is 50, and x2 is equal to 2, right? So by putting all these here, you'll get this particular equation, right? Okay, E is equal to em by 2 into t, and so the average value, E average, can be obtained by using 1 upon 2, because 2 is the time period here, 0 to 2 integration, and then we have E dt, right? So it is 1 by 2, 0 to 2, em by 2t dt. So em is 50 here, so 1 by 2, 0 to 2, 50 divided by 2 t dt. So it is 25 by 2, and t square by 2, 0 to 2. So this would be 25 by 4, and it is 2 square minus 0, so it is 4. So this would be 25 volt. So the average value here is 25 volt. Similarly, we can find out the RMS value also in this particular case, and the formula will be same, which we are using to calculate the RMS value, and that formula is uh, ERMS, so under root 1 by T0 to T E square dt, right? So T here is 2, so 1 upon 2, 0 to 2. So this is em square by 4 into T square dt. So we can simplify this equation and solve. So on simplifying this, question and these equations, we have got the RMS value equal to 28.867 volt, and then form factor and peak factor can be obtained, which are 1.1548, which is form factor value, and peak factor is 1.7319. So this is how we can solve the numerical related to form factor and peak factor, wherein we need to have the RMS value and average value as well. So this is it for today's lecture. Thank you so much.